Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome in this lecture of Module 1 on Advances in Engineering Geology. In previous lectures, we have discussed about different types of engineering geological grounds. And now in this lectures, we will elaborate about geomaterial as concept of rock, concept of rock material, and rock strata or rock strata. Then we will discuss about concept of stress, concept of load, concept of displacement, deformation, and strain. Finally, we are going to look all the discussion in view of stress strain behavior and mechanical view of rocks. Now in this lecture we are going to cover about the rock material, rock stratum or strata, concept of strain, stress, deformation, stress strain behavior, and a brief about the mechanical response of geomaterial. In these lectures, we are going to introduce about the geomaterial in view of rock material and rock strata, stress, strain, deformation, stress, strain behavior, and mechanical response of geomaterial. Friends, as we know, the subsurface and surface view of the earth crust or earth, we can see different type of rock, varieties of rocks, varieties of derived material, varieties of structures like interfaces and others, foliations and others, different type of interfaces, different type of fractures and others, as we have already discussed in case of previous lecture. Varieties of derived materials in form of soil, varieties of transformed materials by biological interference and others, some debris of plants and others. So overall, this zone we can say that one is in transition zone, is a derived material, and in engineering way we are recognizing as a debris. One is a purely changes in form of sediments or in form of the soil with addition of some human and addition of some biological activities by use of fertilizers and others, some debris of plants and others, some additional materials and others. If we are going to see this geomaterial, natural as well as related to the human activity, we can say that can be divided in two forms, in form of the rock and in form of derived material as a soft or the soil. Soil have particularly concerned with agriculture work with some defined definition by additions of biological component and others. As far as rock is concerned, we are going to utilize this rock for the various purpose as a surface for the foundation of the strata, as a surface for foundation of the strata, as a host for creation of number of facilities, underground facilities, and as a material for construction of number of structures like pillars, like building, like pavement of roads and others. If we are going to see this earth crust along with some upper cover in form of soil or in form of sediments or loose materials or weathered material, we can say that this intact portion which is made up of rock commonly traversed by number of interfaces. You can see here this zone is traversed by this interface, this interface, this interface, this interface. In practical, if we are going to see this type of zone and this type of zone, we can say that this zone is behaving differently in comparison to this zone. Here we can see the problem. If this ground is made up of this zone, no problem. If we are going to consider this part is traversed by this interface. If we are going to apply some load and others, the behavior of this zone is different and the behavior of this particular zone is different. The behavior of this zone is different, behavior of this zone is different. As far as rock is concerned, we are going to see it is simply solid in nature. It is composed of mineral aggregates and it is able to show certain type of chemical composition, some specific composition. So we can say that rock is a naturally occurring solid material representing mineral aggregate, possesses certain chemical composition and petrological attributes. However, for this class we are going to add two more terms. The naturally occurring solid mineral aggregates possesses certain chemical composition, petrological attribute, hydrological and mechanical response. Because this rock, when we are going to utilize for engineering purpose, then this rock is going to interact with water, either surface water, either groundwater, going to interact with the applied cause in form of load or in form of stress or in form of any type of activities going to change the load condition either by excavation, either by construction, etc. So we can say in simple way we can say that the rock is a naturally occurring solid mineral aggregate or naturally occurring mineral aggregate solid in nature, possesses certain chemical, petrological, hydrological and mechanical attributes. Or in other words, we can say that it is naturally occurring mineral aggregate solid in nature, possesses certain chemical composition, hydrological and mechanical responses. This rock may be strong in nature, may be weak in nature. This rock, when we are going to utilize for our societal benefit or for practical work, then we can say that this type of intact rock defined by certain parameters are defined under certain parameters like strength, like color, like hardness, like luster, varieties of property. If we are going to define this rock piece under certain technical specification, then we can say that this intact rock is called as rock material. These rock materials we are going to utilize for construction work, for pavement work, for filling work, for various purposes, for making powders, for various engineering applications. As far as the rock zones traversed by number of interfaces, as you can see in this slide, in this photograph, number of interfaces. These interfaces in geology recognized as geological structures of tectonic nature, of sedimentary nature, or deformation nature. These type of, we are not going to elaborate these type of structure in detail, which is slightly out of our discussion. Here we are considering simply this type of interface as a discontinuity. So if the rock is traversed by discontinuity, then there is a change in mechanical hydrological response. If there is a change in mechanical and hydrological response, then the behavior of this is a far different than the behavior of rock material or rock. If we are going to determine the mechanical response of such zone as a rock, which is far different than the rock, then we are going to provide errorful input, and which are going to create lot of problem in stability concerned to construction of engineering structure or estimation of the mechanical response of the ground. Therefore, it is necessary to consider this zone as a rock stratum in geology, and if number is more than plural, as a strata. As the stratum, you can see in geology, this bunch of rock is bounded by different interfaces that is recognized by the geological events we are recognized as the stratum. But for our engineering geological purpose, here we are recognizing this type of interfaces as discontinuity. So in continuum characterization, if we are going to look this zone in view of continuum characterization, then we can say that it is discontinuous in nature. If discontinuous in nature, then the mechanical or hydrological response of this zone is far different than the consideration of rock. Therefore, we can say that this type of strata is made up of not only rock. This type of strata is consisting of rock plus discontinuity. In geological term, we have one term that is the joint, bedding joint, transverse joint, tensile joint, shear joint, varieties of joint, different type of joint having different characteristics. In engineering, this discontinuity we are considering as a trade name as a joint. Joint for any type of interface for our practical use. It may be in geology, bedding plane or foliation plane or lineation plane are fractured. But we are considering here as a discontinuity surface. So this rock plus discontinuity is not, we cannot consider as a rock. It is simply, in our terminology, we are going to define this term as a rock mass. You can use this term rock mass as a single word. You can use rock mass as a separate. So this rock mass is nothing. This rock mass is a geomaterial consisting of rock and joints, or consisting of rock, intact rock and discontinuity. Due to presence of this discontinuity, there is far different attributes in comparison to the rock. If we are going to see overall this, this zone is made up of rock mass, this zone is made up of rock mass, this zone is made up of rock mass, this zone, whole zone is made up of rock mass, not made up of rocks. And technically, if we try to explain, we can say that the rock mass minus joint is equal to rock, or rock plus joint is equal to rock mass. And the rock strata is nothing but it is integration of rock mass. A rock stratum is nothing but it is integration of rock mass. And rock strata is more than one stratum. If we are going to extend this type of rock strata, which is integration of rock mass or made up of rock mass, then we can say that integration of rock strata or stratum is considered as geological or simply engineering geological ground, where we are going to develop some engineering structure, are going to see the problem related to engineering geology. So in simple way we can say that the ground is made up of rock strata, and rock strata is consisting of rock mass, and rock mass is consisting of rock and joint. When we are going to utilize rock for our engineering application related to construction material, or related to building material, or related to decorative material, or related to supporting material, are related to any type of engineering applications, then we can recognize as rock material. In this type of intact rock, under certain technical specification, we are going to recognize as a rock material. For example, a particular rock, suppose piece of sandstone, having certain type of hardness, certain type of strength, certain type of appearance, color, certain type of compactness, certain type of abrasion, certain type of durability, etc. Then we can say that this sandstone is actually rock material. Otherwise, it is simply sandstone rock. Other rock also like granite, like limestone, where varieties of igneous rock like quartzite, metamorphic rocks, etc. We can say that if we are going to utilize such rock as a natural material, then suppose granite, we are going to utilize this material for decoration of roof. Then this granite we are recognizing as decorative stone or flooring stone. If we are going to utilize this granite for making the structure, it is recognized as building stone. So technically the term stone is bounded by except term sandstone and limestone. Generally, if we are going to see the rock under certain specification, then we are going to utilize term stone. For example, gemstone. Simply quartz, we are having mineral. When we are going to utilize quartz for our commercial purpose, then we are recognizing as stone. Feldspar also we are recognizing as stone. So when we are going to specify certain technical characteristic of a particular rock, then we are going to utilize as stone. Building stone, facing stone, construction stone, ballast, pavement stone. So stone is actually trade name or name for the engineering utilization. As far as different structure or different engineering activities are concerned, either we are going to protect a particular type of strata for development of road, development of bridge, foundation, or creation of any underground structure for tunnels, for caverns, for underground spaces, or utilizing this type of pieces as a building material under the foundation of road or rail track, others. In every actions we are going to apply some cause, and cause means force or load. If we are going to construct one building here, then we are going to load this strata. If we are going to excavate this, then excavation induced there is some load on this zone because we have created already gap. So now we are going to see about force. About force, you all are well familiar. Force is simply mass into acceleration. If a particular mass is going to reach a particular acceleration, then we are going to recognize force. In our engineering works, we are recognizing as a load due to weight of overlying material or weight of engineering structure. If this force or load we are going to apply on any, here we are going to apply on any defined shape this force. This force is acting on this area. If we are going to consider this zone, this area, and if we are able to recognize this effect of this force on unit area, then we are going to recognize as stress. So stress is defined as the intensity of the force acting at a point and normal to the plane. Then we can say that this stress, we are going to define this stress is a simply difference of this force acting on unit area where this A tends to close to 0, as small as possible. Here one condition, the state of stress should be same everywhere. Then we can consider here this stress is equal to simply force by area. As far as this concern, here stress we are denoting by letter this sigma. This force, as you know, it is a vector in nature. This force is actually acting, suppose we are considering in any material, we are considering suppose in this body, we are going to determine the stress. Stress is actually a reaction against this applied force. This stress is acting normal to this plane. If we are going to consider this area as a delta A and this effective force and this is a delta F, then we can say that this sigma is equal to delta F by delta A, where this delta A is to 0 limit. Here we can say that this direction of this plane is also defined and this normal is also defined. Therefore, people are recognizing in mathematics as a tensor more than one order vector. If we are going to see about the units utilized for measuring this stress, so stress and pressure in SI units can be recognized as Newton per square meter and by m square in short. A particular unit we are going to define as a Pascal denoted by PA, and for engineering purpose because we are working with the huge load, therefore we have started utilizing a bigger unit and that is known as megapascal, MPa. This megapascal we are going to utilize is a mega Newton per meter square, and gigapascal, kilopascal for soil and others. So these mega, giga, tera, kilo, these are as usual as we are going to utilize for other units also. If we are going to see the different type of stress, then we can say that we are able to define this state or classify on the basis of direction. It is uniaxial or biaxial or triaxial. It is uniaxial or biaxial or triaxial. As the name indicates, tri means 3, bi means 2, uni means 1. One directional, two directional, three directional. On the basis of nature also, it is a compressive, or it is a tensile, or it is a shear. Others also twisting and torsion and other. Then we are not going to consider these aspects. Because we are working either in compression zone, either in tension zone, either in shear zone, either in, so the deformation or failure of material is due to compression, tension and shear. Our engineering geological work is having business with these type of stresses, not torsions and others in general. If we are going to see this stress, it may be incremental, means continuous. Suppose the stress sigma 1 is 1 MPa, sigma 2, next time sigma 2 is 2 MPa, sigma 3 is 3 MPa. So continuously time is increasing and there is increment in stress. That is incremental in nature. In certain conditions, suppose one rock slab is located below a 10-ton load, then it is a constant type of stress. In certain cases, we are going to suppose a motor is traveling on a stone paved road for a particular time t1, then going to leave this pavement at t2. Then again next t3, next vehicle is coming to load this pavement t3 and then leave at t4. So this strata is experiencing loading and deloading, stressing and de-stressing. Or in another case, if you suppose any rod, if we are going to compress, then going to pull, going to compress, then going to pull. So in this situation, the stress is a cyclic in nature. Then if we are going to see the stress in view of the time, then we can say that in variation incremental in nature in short term, short time variation, and constant in nature or incremental in nature in long term variation. The deformation of rock at constant stress with respect to time, considerable time, we are recognizing in our geology, in physics or in material science and in engineering geology as a rock creep. So about this we are able to categorize stress, that is the ratio of force and area of action, but condition is this area should be as small as possible, close to 0. Force acting at unit area, and it is a vector in quantity in general, but in detail we can say that stress is a tensor. Stress can be divided on the basis of direction of the forces acting in uniaxial, biaxial and triaxial condition. In uniaxial condition, the stresses are acting opposite to each other, are away from each other, are tangential to each other in uniaxial direction. In biaxial, acting from the two sides, and in triaxial, in acting from all three sides, as we are going to recognize this side and this side. So all the side we are recognizing as a triaxial. If we are going to see the nature of applied load, it may be working opposite to each other. We are going to recognize as compression. If we are this type of forces going to act away from each other, then we are going to define as a tension or tensile. If this type of force is a tangential in nature, then we are going to define as a shear. There may be continuous increment in stress. If we are going to see is increment in stress, this suppose this rock sample or rock is subjected to incremental state with respect to time. Suppose is a time 0, no problem. 1, 2, 3, 4, 5. The 1, 2, 3, 4, 5 is the time. There is a continuous increment in stress. Continuous increment in stress. This type of stress condition is increment. Constant, we having some constant value, and this body is subjected to continuous a constant. In another case, we can say that in 0 time there is increment in stress and up to 1, and then at the end of this T1 there is a fall in stress. Then again increase in stress, then fall in stress. Increase in stress, then fall in stress. This type of state is a cyclic stress. It may be change from the compression to tension, or simply compression and 0. No stress. Loading, deloading. Stressing, de-stressing. Stressing, de-stressing. Either in another way, we can say that similar to our this sine curve and others. If we are going to consider this compression, stress condition, here tension. So in this 0, no problem. In first time T1, there is increase in stress level. In time T2, it becomes 0, and in time T3, it reaches to tension. Then again becomes 0 and again goes under compression. Then again 0 and again under tension. So in this way also, but in case of rock, this situation is not possible. Only we are considering compression and decompression. Tension, detension. Shear, de-shear. In another case, we are considering two things. One is for general use, that is the quasi-static type of stressing, and another is a time-dependent stressing that is useful for determining the aging effect. Similar to the human, the rocks is also feeling tiredness and weak, and ultimately fall under failure condition. Before discussing the effect we are going to discuss about the deformation in brief. The variation in shape or change in shape due to applied cause. Applied cause here may be due to human activity, due to nature, and technically we are considering here force, is known as deformation. It means the material subjected to or rock subjected to external forces exhibit deformation. Here we can see that if this type of body in 2D, we are going to provide tension, pull, then this type of body may show this type of shape, extended shape. If we are going to compress this, then this dimension is extended when this type is compressed. So change in shape. If we are going to apply shear here, tangential type of stress, then this type of going to make this. Next aspect is a displacement. If we are going to put any point here and if it is under the stress, then this point is going to show the position is here. So displacement at a particular intensity of this stress, and engineering we are recognizing as a load, there is a displacement delta D. So similar way we can say that this force resulting the displacement delta D. This displacement, suppose we are putting here 2 points. This point initially was like this, but now able to show this type of extension shift. If we are going to see this type of displacement of noted point with respect to the original, then we can say that it is straight. So the ratio of change in dimension and original dimension. If we are going to observe variation in dimension with respect to original dimension, we can say that straight. This dimension may be linear, one directional, may be area type, may be volumetric type. So if there is a change in linear fashion, we can say that linear strain. If change in area, then we can say that aerial or area strain. And if in change in volume, then we can say that volumetric change. So if we see here in case of the linear, we can say that the change in length of rock samples or any object with respect to original length is recognized as linear strain. If we are going to see about the dimension, this delta L is also has same dimension, this L is also have same dimension. So M by M is dimensionless. So linear strain is a dimensionless. Similar, if we are going to consider aerial change, if there is a change, this type of zone under compressor or any changes in form of this, there is a change in area. So if we are going to see the change in area with respect to original area, we can say that area strain or aerial strain. Change in area divided by original area. meter square by meter square, no dimension, dimensionless. Similarly, volumetric, in this case, if there is a change in volume, then we can say that the change in volume by original volume or with respect to original is recognized as volumetric strain. In general fashion in engineering, we are utilizing the symbol psi for presenting strain. This is a Latin word, and for stress we are utilizing this sigma to define stress. As far as unit of strain is concerned, have no unit and dimensionless. Next type, if we are going to see the stress and strain, here if we are going to plot strain and here if we are going to plot stress, 0, 1, 2, 3, 4, 5, 6, 7 and all multiplied individual 1 into 10 to power minus 2 or minus 4. Then here in MPa, zero 0.5, 1, 2, 3 or 1.5, 2, 2.5, 3 like this. If we are going to stress, here I try to show one sample with help of this 2D diagram. If we are going to compress at time t0, we are not going to apply any stress on this. At time t1, we are going to apply 0.5. Here t1, t2, t3, t4, t5, t6, t7 is like this. So at the time t1 we are going to apply 0.5 MPa load. Then with respect to the 0.5 MPa there is increment in strain. Then going to 8, 0.5 more, 0.5 MPa more at 1, then there is still going to, this stress is going to create strain. So we are getting this type of strain lying between this 1 and 2. Then in next we are going to see increment in stress, then going to see increment in strain. If we are going to recognize this portion, some portion is linear following Hooke's law. Therefore, if any material is able to show this type of stress strain behavior, then we can say that this material is following Hookean's law, where the chain development in strain and stress is in form of proportion. Following the proportional law, and if we are going to consider this, we can say that this is the elastic material. This zone is a non-linear and there is a lot of discrepancies among the researchers and engineers. As per my view, This represents the non-elastic zone as initial stage. If we are going to see, for example, any rocks, particularly sandstones having some grains, some voids and others, when we are going to compress this, initially what happens, some of the constituents going to show intactness by moving towards each other, and due to collapse of such type of gaps in form of voids or cracks or others, the samples initially going to enhance stiffness. Stiffness we will discuss later on, but here so going to show the collapse of all the and become higher stiff, then it started behaving elastically. Again, if we are going to see here, this elastic behavior is started deflecting, and this point we are going to recognize as yield point. Again, it is working as a nonlinear and reaching peak. This peak is representing the failure point or peak point. After this rock is unable to bear the load and the build-up stress is started declining. Therefore, this stress state, although there is increment in stress, but increment in the strain, but decrease in stress. So in this way, if we are going to divide this zone, we can say that this is the pre-peak zone or pre-failure zone, and this is the post-peak or post-failure zone. The different characteristics of pre-peak and post-peak are widely utilized for proper designing or understanding the behavior of ground, fractured ground, fragmented ground, intact ground, jointed ground, etc. So, next class we will elaborate the next step. For this, you can take the help of online material through some website, and by utilizing any rock mechanics book, and in addition to this well and this Kashavalu and the Waltham engineering geology. Now we are going to conclude. Geomaterial can be divided as rock, soil, rock material, rock stratum or strata. The stress is a force per unit area, and the stress can be divided as compressive, tensile, shear, uniaxial, biaxial, triaxial, incremental, constant and cyclic. The deformation is actually change in shape. The strain is a ratio of change in dimension and original dimension of a rock sample of or any material. It may be linear, it may be aerial, it may be volumetric. The stress-strain behavior is representing the behavior of rocks under stress. Dear friends, in this class we have discussed about concept of geomaterial, rock materials and rock stratum or strata. Then we have discussed about the concept of stress, different type of stress, deformation, concept of strain, various types of strain, about stress-strain behavior and some initial steps in mechanical response of rock. Thank you.